Hello there and welcome back. In this video, we're going to begin our shot for the next 2 weeks by doing a 3D track and laying it out. So let's go ahead and get started. All right, so we have a blank nuke script here. Let's go ahead and import our footage for week 5. So we have this right here, and we just want to make sure that everything is set up correctly. First, we're already in ACES thanks to our handy defaults. Let's make sure that our frame range is correct. We'll go into our settings right here. That's looking good. HD 1080. Again, we're going to end up cropping this, but we can work on it in 1080p. And frames per second is good. OCIO color management is good. All right, so we are good to go. It's just that easy. All right, so let's take a look at this shot now that our project is set up. This is what we're going to be dealing with for the next 2 weeks. You can see we are slowly pushing forward here. We have a fully CG foreground we're going to add in, and in the deep back we are also going to do a little matte painting. And with our 3D track, what we'll really need to make sure is nice and sticky is the ground interaction on him. We want everything to be sticky, of course, but the main thing that really needs to stick are the areas that he's interacting with. So when we're pulling a 3D track, we'll definitely put some extra emphasis on this area. So let's go ahead and get started. Before we do any 3D tracking, we're going to want to pull a denoise on this guy. It's a pretty noise-free shot, but it's always a good first step. So we'll just pick a patch right around here. And let's just AB. Make sure that we're getting rid of all of our grain. Just smooths it out a little bit. And we'll go ahead and write this out. Again, if you don't have reduced noise, I'll go ahead and give it to you in a separate file. I'll just go ahead and make the file path for us right here. Create directories is already on, so let's go ahead and render this out. All right, that's complete. We'll bring it in. Okay, now we have our reduced noise version, and the next step with 3D tracking is to get an undistorted plate if you have one. I do have one here. If we go into our footage folder, we'll have this undistorted plate. I filmed this with the exact same lens and camera settings just off my monitor, so we'll go ahead and make a lens distortion. We will go ahead, analyze, and hit detect. Let that process for a second. And it looks like we have one bad line in here. I'm just going to delete that. But everything else looks pretty accurate. You just want to kind of scan through this to make sure nothing else is crossing. And it looks pretty good. So let's go ahead and hit solve. All right, now we have an undistorted plate here. Let's go ahead and copy and paste this. And now when we turn it off and on, we've gotten rid of the distortion. Not a ton of distortion on this lens. This is a 35mm that I was using. And now we're going to want to start 3D tracking our shot. So let's go ahead and make a camera tracker node. This is going to be very similar to what we did in week 3. And what we can do in here is turn on preview features. We can make the number of features maybe like 700. Try to refine the feature locations a little bit. And we can see that we have a problem here as we're scrubbing through this. The 3D tracker is trying to track our character, or at least it would be if we hit track right here. And so we're going to need to make a little mask so we don't end up tracking him when we're trying to track the rest of our scene. So what we can do is let's make a planar tracker node. Why make this any harder than we have to? We can just throw it in here. Let's make sure we have our planar tracker layer selected, and we'll just roughly draw a shape around our character here. Doesn't need to be super tight because we actually have a lot of data in this shot to 3D track. We have all of this over here, all of this in the background. If there was not a lot of good data to track from, maybe we would want this to be a little bit tighter, but I think this is fine for what we have. Let's go ahead and turn off perspective and shear and rotation. We only really want the translation and scale of this shape. That should make this a little more accurate. And let's just track forward. All right, and that planar track is done. We should maybe keyframe this a little bit just so it sticks maybe a touch tighter. We'll stick auto key on and key our first frame. Go to our back one. This looks pretty good. And we can just maybe scoot this back in a little. Maybe just move up the bottom. just to make sure we have it a little bit tighter. We want these details on the side. That's kind of why I'm doing this right here. All right, and I want to make sure that in these in-between frames, we're not accidentally missing any of him. So what I'm going to do is similar to how you can hit R for the red channel, G to show the green channel, and B to show the blue channel, you can actually hit M, and this will show you a matte overlay, and this will make it really, really easy to see where our alpha currently is. You can see how that lines up. So I'll hit M, and we'll hide our overlays, and let's just kind of scrub through this and make sure our character is covered this entire time. Looking pretty good. Just want to make sure nothing happens or leaks out. All right, great. That planar tracker made it very, very easy. Took 2 keyframes and we have a really good garbage mask. So we can make sure that our alpha is being properly fed by the planar track. Take a look at our camera tracker node, and let's go ahead and change the mask to source alpha so he is not included. And now we just need a little bit of information about our camera. We know the focal length. It is a 35 millimeter. Our film back size, this was shot with the Blackmagic Pocket 4K camera with an adapter on it. So once you run and crunch the numbers, it is 25.53 by 14.35. And I don't think we really need to change any of these other settings. It's not a particularly smooth camera move. It is in fact a bit shaky. And then I think the very last thing we can do here is add a little high pass. It never hurts to just contrast your image up some. Looks like it shot up into the corner for whatever reason. All right, let's change this mix to be like 0.5. And let's see, it looks like this wants to track our clouds. I think that will probably be fine. We'll just keep a look in the results in our auto tracker. So let's go ahead and hit track. And now our tracker has completed. So let's just hit solve and see what that will end up giving us. So we'll just let that calculate for a second. Almost done. All right, an error of 0.6. So for 1920 by 1080, that is pretty good. We can see where all the points that it thinks are sticky are. They're all kind of around this area. What I do think I'd like to do, it's always good to just add a couple of user tracks to your 3D track. So I'm just going to grab a couple of key positions in here with our standard 2D tracking node and just make sure they're really, really sticky all the way through. And so what I'm going to do is just place maybe 6 to 8 trackers on the ground using our tracker node. This is nothing new. We're going to use the same techniques that we used in week 3. So I'm just going to skip to the end when I have all of my tracks completed. All right, so I placed around 8 trackers. You'll notice I placed them pretty much all around where our character is walking just to make sure that these areas are extra sticky. I also placed one on either side of this line right here because I know this is something we're going to want to paint out in the future. And so we'll just have a good reference point for where that is. And yeah, just trying to place these where we need our track to stick the most. So let's go ahead into our camera tracker and we can import a tracker from tracker 1. We'll hit OK and let that wait for a second as it loads those tracks in. All right, here they are. Let's go ahead in here and let's hit solve. We'll see what we get now with those in. Maybe it'll go down from 0.6, maybe it won't. We'll go ahead and see what this does for us. We do know it will be more accurate in this zone, so it went up 0.01%. It's technically a little worse, but it's sticking in the area that we want more, so I'm going to say it's technically better. And so we can just kind of lower these to find the bad tracking points. And you can see this is really, really sticky. So if we delete our rejected right here, we can see we're down to 0.4. That is pretty darn good. We can also see it's not really using any of these that are super high up, and that is fine. All right, so it seems like we have a pretty sticky track on our hands. So now it's time to go ahead and lay this shot out. If only we had some geometry for this setup. Well, actually, we do. Remember back in week 2, we've already laid this exact scene out. So I'm just going to paste in that little setup here, and we already have what we're looking for actually. This will work really nicely for us. The dimensions haven't changed at all. This is the exact same location, the exact same shoot day. So let's start laying this out. So the first thing I want to do is make sure Scene Plus is selected, and let's just go ahead and create. And now we should have a point cloud that we can see. And if we were to pipe this into our scene, I'd imagine it won't align very closely. And we can go ahead and confirm. Yeah, it seems rather small, and also it's not really aligned to any one direction. We want to make sure our scene has right angles in it so our fence isn't going off diagonally. That will just make it easier to work later. And so let's go into our scene and start adjusting. What I want to do is use this point as our origin. So I'm going to go ground plane, set origin, and that should snap this to be right dead in our center. And then what we can continue to do, let's select our user 1 track. We'll grab this user 2 track all the way to the right, and we can set that to be our X so that that part is flat to the ground. And then right here, we'll grab our Z and just make sure that this is flat as well. We'll go ground plane, set Z. So now if we look at this in 3D space, we should theoretically see a bunch of right angles. So let's look at this from the front. And we can see this fence is pretty darn flat. There may be a couple of slipped points, but we can see that this is looking very flat. The angles are all looking correct. And so this is looking pretty darn good. So let's go ahead and see how this compares to our scene. So we're starting to get closer, but the scale isn't quite correct. So let's go ahead and fix that little scene scale issue. So if we go into our camera tracker node, we're actually going to learn a new way to kind of set scene scale. If we go into this user 4, we can select that. This is on the ground. Then we can go to the top of our fence here, which is this guy. And we can actually say scene add scale distance. And what this will do if we go into our scene tab is it will set up this scale constraint. Those 2 points are now represented by this dist1. And right now we have not input any values into it, but we can tell it exactly how big the distance is between these 2 points. And how tall is it? Well, we measured our fence earlier, so let's just go ahead and grab the scale right here. We can copy that, and then in our camera tracker, we will paste the scale, and that will scale our entire scene. You can see it scaled it up by about 8.2 at the bottom, and let's take a look now and see how this is aligned. All right, so this is very, very close now. We can see everything is starting to look good, but we're still not quite perfectly aligned with our scene. And so what we can do is go back into our camera tracker. Let's just kind of scoot this guy over until our fence is a little bit more closely aligned. You can just keep going and nudging it. Something like that is looking pretty good. Remember, we set our origin to be this section right here. That's why that is the flat ground plane, because our dirt actually goes a little bit below where we have our little flat plane here. If we look at the footage, we can see there is a little bit of a divot. So in a way, our scene setup could be even more accurate, but we're using it as a guide. And I think this is starting to look pretty great, if you ask me. If we look at these points, they're starting to intersect with the ground. Maybe what we could potentially do is lower them a little bit. Let's go into our camera tracker point cloud. Let's make these something smaller, like 1. And let's go in here. Maybe we just lower our scene just a hair. That was way too much. A very small amount, just so they start intersecting the ground just a little bit more. Maybe something like this. All right, so that is looking pretty great to me. This sits within our scene well. If we wanted to, we could scoot this all the way back with our Z to align the green screen so we're in the exact same layout of what we had previously. But, I'm not too concerned with that. If we really wanted to, we could. We know how to do that using this tool. I want to keep this around the origin. All right, so I think this is looking pretty good. I think it's time to start fiddling around and seeing how a wireframe looks over our footage. So let's go ahead here. We can get rid of this background pipe and this undistort. We don't really need that. We'll pipe our layout into our scene node, move this over here. And we still have these wireframes left over from our previous. So let's go ahead and just look at this. This is what our scene layout's looking like. Let's merge this over our undistorted plate. All right, so obviously this is a little bit hard to see here, and we can change this to plus. And obviously we have some rotational issues here. What would happen if we rotated down a little in X so that that horizon line starts lining up a little bit more closely? Just keep going up, something like this, I think. Starting to get closer and closer. And that hill starts to go up, so I think that's not too bad. And it even looks like maybe we can do a translate a little bit so that our edge of our road is a little bit more closely aligned. And then maybe we can also rotate this a little bit on Y, just so that lines up as well. And our fence may look a little bit tall, but that is also because our ground is not moved down at all. And this fence is also not quite uniform along the whole path, but I do think our ground looks pretty correct. Looks like we may need to start rotating in Z just a little bit to try to line this crack up more. And I think we can give this a preview and see how it's looking. This perspective looks like it lines up pretty closely to me. And so let's go ahead and just give this a little bit of a preview. All right, so we have this previewing now, and it's looking pretty sticky if you ask me. I'm not seeing any super noticeable sliding, but you know, the best way to check your tracks is with a stabilize, and this is not really going to be any exception to that. So let's go ahead and make a stabilize. We can pick any of these manual trackers that we have here. Let's find one that goes all the way to the end, perhaps, maybe like this track 5. And I'll just set that one to be active. And then I will make a transform stabilize here. Just throw it underneath our merge. Best to be thorough about these things. And instead of a wireframe here, I wonder what would happen if I gave this some noise instead, just so there's a little bit more of a well-defined pattern. And obviously this is kind of stretching out like crazy. Let's go ahead and change, I think, the X size. It might need to be the Y. We'll find out. It's not the X size. Let's change this down so it's a little bit more of a noticeable pattern. We're just trying to get some texture to stick to the ground so we can tell if this is tracking or not. All right, there we go. We'll gain this up some so we have some really, really bright spots. And we can also do on this sidewalk, render textured plus wireframe. Now we'll get the best of both worlds. Maybe just change this mix down to 0.5. Let's really try to contrast this up. And I don't think we need the point cloud in here either. Alrighty, so let's go ahead and give this a preview. All right, so this is done previewing now. Our super texture is in here. Let's go ahead and take a look at this. Just kind of scrub through. This is going to be the area where we're going to be able to see if there's any slight shifts. And that looks nice and sticky. Great. We could check this area. It's going to be a little bit harder because it's still moving so much. Maybe what we should do now is just kind of swap the tracker that we're checking this with. Let's go ahead and take this off. Let's grab our track 1, perhaps. That's going to be more in this area. And then we'll turn that on. And since our stabilize node is expression linked to our tracker, it will auto update. So we'll give this guy a preview as well. All right, so this guy is stabilized. We can go ahead and check it out and make sure that this near part is sticking as well. And there's a bump right here, but that is because our stabilize stops. That's not a track error. And that's looking nice and sticky as well. We can look over here. And again, it's a little bit hard to tell without a stabilize. It would be nice if there was a way to check this entire section of road without having to do 4 different stabilizes? Well, there actually is a way that we can do that. We can use projection and 3D cameras to stabilize this road and make sure that it's perfectly sticky. And in a way, we've already done a variation of this in week 3. And so let's take a look at doing that. What I want to do is grab our sidewalk and let's go ahead and project our undistorted plate onto the sidewalk. We'll plug in this camera and we can take a look at it. And this is a little funny looking now. It looks like there's a cutout slice. And that's because it's actually using the alpha from our roto here to cut out our shape. If we just turn that off, we can actually see we have our road right here. And I don't want to check the entire road. I just want to check maybe this section. And let's go ahead and just scale this down in Z pretty significantly. We'll do maybe 10, something like that. Let's do 20 maybe, and we can scoot this down. Something just like this. So now what we can do is go into the scanline render, pipe in our card, and let's change this to UV. And if we look at this now, this is our projected street. I'm going to go ahead and make a mirror so that it's right side up. And if we start playing this back, we should see this be pretty much perfectly stable. If this doesn't move around at all, that means this is a really good track. We are going to see certain sections of this slide around, like the dirt on the side and our green screen, because those aren't on the plane that we're checking. Let's just go ahead and let this preview and see what it ends up looking like. All right, so we have our stabilize here. Let's go ahead and see what we have. All right, so it looks like our near part down here is pretty darn sticky, not really seeing any movement throughout the shot as the camera is moving. And that means that's really, really sticky. And the best thing to do to really check this is check your first frame by hitting the home key and your last frame by hitting the end key. And you can actually see we have a little bit of slipping happening in here. This is scooting down towards our shot, and that means our track isn't 100% correct, or that our geometry isn't 100% aligned. And this is why it's so great to use a card to check your stabilize, because it's so accurate in showing you your errors. And so let's see how we can fix this a little. I would imagine we kind of broke something when we did our little hand rotations. We weren't really adjusting based off of these points, and I think that's likely where we went wrong. And so let's go ahead and check this out. We have a couple points back here. Let's go ahead and just make an axis right there. And we may as well make another one. We can make an axis around here as well. We'll create another axis. So now we just have 2 axes that we can use as a reference point. So let's just take a look at this. And if we look at these guys, let's look from the left side. And we'll just hit F to find them. Let's see how they compare with our current ground plane. And we can see they're actually floating a little bit above. And I imagine that is why they're slipping a little bit. And so what we can do in here, let's go into our camera tracker and also shift click our card sidewalk. And let's update our camera's rotation. These axes won't necessarily update with our rotation, and so I think I'm just going to delete them and get rid of them. And now let's go ahead, go back into our left side view, and we'll just align these points. That's where our 2 axis nodes were. And let's go ahead, go into the camera tracker and make sure that these are correctly aligned. So we're just rotating down in X until the points are intersecting with the ground. And here we go. I think that looks pretty close to me. It's also important to know it's rotating from our origin over here, so we're not changing our near points really at all. So now let's take a look at our stabilize and give this a little preview. All right, we have this guy previewed now, and let's take a look right here. And we can see these pixels are staying pretty much in the exact same place the entire time. If we look at the first and last frame, maybe there's a tiny little shift up, but it's absolutely nothing compared to what we had before. And something to also keep in mind is that these are maybe like 2 pixels that are getting super blown up. And so throughout the course of these entire 200 frames, maybe it's shifting like 2 pixels. And I think that is more than fine. 2 pixel shift, that's 1 pixel per 100 frames. If someone can catch that slipping, they have much better vision than I do, but I think that is more than acceptable. And now let's take a look at what this new camera looks like when it's merged over. And let's go ahead and get rid of our noise. We'll bring this back to just being wireframes like this. And we can see right now, this does not look very good. It's not well aligned. And why is that? Because this sticks much better now. Well, the answer simply is that our real world is not built to perfection like the computer is. And that probably sounds like a very obvious statement, but when dealing with 3D tracks, that especially rings true because our footage here is actually a little bit on a hill throughout this entire area. You can see there's a very obvious one at the end, but there is a little bit of a curve to this. It's very subtle. You can see it a little bit in the fence. It kind of goes up and down. The fence itself isn't super consistent, but this isn't a perfectly flat surface. And this entire time, we've been trying to make it work on perfectly flat surfaces. And so what do you do? Do you sacrifice your overall perspective for the sake of making your track stick? I would say it's much more important to get your perspective to be accurate and then make some non-perfect geometry for a ground here, because I think that most accurately represents the real world. If we wanted to, we could just leave it like this and use this piece right here as we currently have it. But since we're going to be using this in 3D, I really want to make sure that our perspective is correct. And so I don't want to end up using what we have right here. And so if we go into our camera tracker, we can go ahead and adjust this back down a little bit more, try to make everything just align a little bit more closely. And let's just go ahead, we can turn off our wireframe and see how this is looking. And we can just see this all aligns much more closely now. And that's really what we want at the end of the day. We want this perspective to kind of line up. If this kept extending, it would reach our car right here. And so I think this is a pretty good layout from a perspective standpoint. But now we need to go ahead and make some geometry for our ground that is actually sticky. And so let's go ahead in our camera tracker node. We can go to an earlier frame and let's grab a point on our ground. We can grab this user track right here, since we know this will be pretty accurate. And let's go ahead and create a card. And that'll just make a card off to the side here. And let's pipe this in. We can just give this a wireframe as well. And let's take a look at it. All right, so we have a card right here. Its pivot point is perfectly in the center of that tracker that we selected. If we open that up here, we can see those are nice and lined up. So let's go ahead and start tweaking this a little bit. Let's change it so that it is set in the ZX orientation, and also get rid of all of this rotation that's on it. I want it to just be flat for right now. And another thing that I think is important is getting this pivot point to be at this corner. And so with our X, we can just change that pivot to be -0.5. And to bring it back into place, we can add 0.5 right here. That'll slide it back to where it was. And then for Z, we can slide it forward 0.5. We'll need to make sure we uncheck image aspect because you can see it's not perfectly in the corner right now, and now it is. And in Z, we can subtract 0.5. Again, this is just bringing it back to the original spot of our camera tracker, and we can just reopen that to just confirm that this is working as expected, and it still is. All right, so we have a card right here, and this is going to be just our tracking sidewalk. Great. And let's go ahead and just start playing with this a little bit. We can scale it up, and we're gonna want to extend it further down the road. And now what we need to do is figure out where it needs to be tilted to get this area to stick. So that should be pretty easy. We'll go into our camera tracker here, and let's grab this point. It's right there around that area, and we can create an axis. You'll see this process is pretty similar to using Model Builder, but since we have points already from our camera tracker, we may as well use that. All right, so if we take a look at our card sidewalk and our axis, let's just look at a left side view of both of these. We can grab our sidewalk card and let's just rotate this in X until it approximately aligns with that axis. Something like that should work pretty well. All right, let's go ahead and take this and put it in here, and we can check a little stabilize on this guy to make sure everything is working as expected. And we can see right here that we're not quite catching the left side of our sidewalk, so we can just grab this here in our 3D view and move it a little bit to the left. Just something like that. We just want a little overlap. All right, that's looking good. And I also want to see this maybe in a little bit more detail because it's a little bit squished down vertically right now. Let's go ahead and make a reformat, and we can just set this format size to be square 2K, and that will just allow this to be a little bit larger. And so we have some reference to check against our track. Let's just make a grid. Maybe we can set the number to 20 and the size to 3, just so we can see it a little better. Let's go ahead and just give this a preview. All right, so let's take a look at this area. And again, these are like 1 or 2 pixels that are really being stretched out here, but you can see they're very steady from the first frame to the last frame. These hardly move at all. This is a very, very tiny, tiny shift. This is probably even less than what we had before. And doing the home and end keys will show you the first and last frames, but it also looks like this is potentially slipping a little bit more than we want to. And so how do we fix that? Well, we'll just need to edit that part of our geometry. Let's go ahead in here. This is the line that's right behind our green screen. In our camera tracker, we can find a point that we trust. We can grab this guy perhaps. Let's go ahead and just make an axis. This will be another reference for us. And then if we compare this axis with the side view that we have, let's go ahead and see if those are aligned or not. You can see there's just a little bit of a difference right there. So let's take a look at our card, and we want to find right around where that line is, right here. And I think this is something we could modify. So you can actually modify Geo in Nuke. It's a little clunky, but each release it does get a little bit better. Let's go ahead and make this so that there are only 2 rows. So we have this guy right here, and we can make an edit Geo. And with the edit Geo selected, we can go into vertex selection mode, grab these guys, and then we'll have to open the edit Geo again to make sure that our handle is selected. And all right, with these guys, we can go ahead and start moving it. Our axis alignment is set to object. Let's go ahead and place this right where our crack in the ground is. And then we can go into our left side view and select our axis. We can just scoot this down a little. The more closely that these are aligned, the better. All right, great. And we've just done a little geometry modification now. Good, good, good. So now if we go to our first frame and our last frame, we can see that this doesn't move at all. This is rock solid, where if we turn this off, we can see there's a little bit of shifting that's happening. And so that's really what you're after. You want these pieces to move as little as possible. I know that this piece back here shifts a tiny bit, but again, these are like 2 or 3 pixels that are getting blown up, so I expect there to be maybe a little wiggle room with them. So I'm not too concerned about that. If we wanted to, we could go ahead and check and make sure this is aligned with our axis, make sure it wasn't accidentally bumped at all. We'll go into our left side view and we'll try to compare with that. and we can see that this is still pretty darn closely aligned. Maybe if we really wanted to, we could rotate this just a touch more in X to get that even closer. But as we rotate there, we are going to want to make sure that we didn't mess up our alignment with axis 2. It is a little bit annoying to work like this, but you know, it's the best Nuke has. Really, you should be doing this in a modeling program, but we're just trying to keep it all in Nuke. Now let's go ahead and see if we hit our home and end button. That is not moving at all. That's rock solid. This is definitely the most important part to get sticky because that's where we're going to be doing our paint outs. And let's go ahead and preview this and see how it looks. All right, and this preview is done and playing back now, and we can see this is nice and sticky throughout our frame range. There might be a little bit of jittering in this furthest section here, but we're not too worried about that. And also, these are like 2 or 3 pixels that are getting blown up to be maybe like 10 or 20 pixels, and so there's always going to be a little bit of jittering in there, but the important parts that we need to stick are right here, and these look nice and sticky to me. And so it just shows that it's really important to be able to check your tracks correctly. Using this card stabilize method is definitely the most thorough way to do it. This 2D stabilize, we didn't really catch any of these problems, which potentially means we didn't need to go through the trouble of creating this and kind of tweaking our setup. But I think it's good to be as thorough as possible when working, because details like that could come back to haunt you if someone catches it down the line later. And so let's go ahead and see what this looks like if we take our edit geo right here and merge it over. We probably need to have this be textured in wireframe so that it shows up. And let's make sure that's connected. All right, so we have our little track right here. And let's go ahead, maybe we can throw this grid on it so that we have even more points to check. Let's go ahead and give this a preview here just to make sure that this is working as well as we think it is. All right, and this is previewed now, and it looks nice and sticky on our ground. This section looks really good right here. I'm not seeing any noticeable slips. If it was slipping, our stabilize definitely would have showed us. Back here, these are the like 3 pixels that I'm talking about. You can see how sticky this looks. That stabilize was just over exaggerating every tiny sub-pixel slip. I don't think there's anything noticeable going on back here, but it's always good to check. You don't want to just assume that you can't see it based on that stabilize. And so, yeah, we finally have our track done. And now we can go ahead and move on to slap comping. We do need a 3D track to get CG renders, and it'll allow us to accurately track in some background elements. So it's time to start slap comping and figure out what this shot will look like in our next video. So thank you very much for listening, and I'll catch you in the next one.